Okay, so the TCP from the perspective of cybersecurity or network security. So let's first read out what it is saying here. TCP sync flood attacks. So most common attacks that we face are TCP sync flood attacks, TCP reset attack, and session hijacking attacks. And we have already talked about these because these two are the most common attacks of denial of service attacks. Session hijacking is the man in the middle attack. Man in the middle. Okay, so the TCP sync flood attacks exploit the TCP three-way handshake. The figure shows as threat actors continually sending TCP sync sessions request packet with a randomly spoofed source IP address to target. The target devices reply with the TCP sync ACK packet to the spoofed IP address and wait for the TCP ACK packet. Those responses never arrive. Eventually, the target host is overwhelmed because it cannot handle so many TCP sync requests. So with half open TCP connections and the TCP service are denied to legitimate users. So this is the whole idea of the attacker. They do not want you to use some good website like Job Skillshare. So they will try to send so many TCP sync attacks. So the TCP flood attacks are stopped by setting up the robust. So this is the mitigation. But as you can see over here, this is the display filter. It is saying sync packet is 1, sync packet is 1, whereas the TCP flag acknowledgement is 0. Means I am sending the sync packet, but I am not getting back the acknowledgement. So this you can see the source is this system, then source is this system, then this source. So you can see we have multiple source, but they are going to the same destination with the same protocol TCP with the same length of 174, and you can see what kind of packet it is. It is sync or the flag. What kind of flag it is? Sync. It is sending sync, but we are not getting acknowledgement back. This is a clear indication that Wireshark is showing us that this is a TCP sync flood attacks. And on the same fashion, TCP reset attacks works as well. I hope you get the idea. So TCP flood attacks are stopped by setting up robust filtering rules. Networks can identify and block malicious sync requests based on specific patterns or known malicious IP address. Most operating systems attempt to limit the. So basically what it's trying to say, we are going to limit some sync packet. For example, if this is a server and we limit sync packet to only let's say 15 in some fraction of time, in some span of time. So as you can see, this is the time slot over here. You can see 351.6 millisecond, 351.6 millisecond. So these are all occurring on the same time with a sum of fractions. Okay, so we can set sync packet maximum 15 in the spanning time in the span time of let's say uh, mm, let's say 5 millisecond. So in this span of time, if we hit 15 sync packet, my server is going to block this request. So this is how these TCP sync flood attacks can be mitigated. Similarly, the TCP attacks happens, we have UDP flood attacks as well. So this is also happen in the same fashion. As you can see over here, source is 172.79. This time we have same source. It means we have one source who is trying to attack. Destination is going to be similar, same, but we are going to use multiple protocol like UDP, Echo, most of them are UDP. Source port is same, but the clear indication that this is the attack. You can see the destination port is going to be incremented by 1. As you can see, 1, 2, 3, 4, 5, 6. So it started with destination port number 1 and incremented all the way to 65,535. So this is a clear indication that UDP attacks has been happened. Okay. So this the program will sweep through all the known ports trying to find the closed ports. This will cause the server to reply with the ICMP port unreachable message. So this is for the ICMP ping attack. Okay, but UDP and these are all common attacks basically, because there are many closed ports on the server. This creates a lot of traffic on the segment which uses up most of the bandwidth. So this is what a hacker wants to do. They want to utilize bandwidth. They want to choke this bandwidth so user cannot access the services. So common interview question and answers and assignment. So is UDP better than TCP? What is the port number of this is basically SSH? Telnet and DNS. How does TCP works? List out common TCP and ports and protocols, and this is also the same. What is the difference between TCP and UDP? What TCP three-way handshake process? What is PPAR? What is sliding window? And what is socket? So two things I'm going to give you. PAR is positive acknowledgement with retransmission. You remember that if I'm going to send some sequence number, let's suppose I send sequence number 100 and server is going to acknowledge bit 101. But what in case if this acknowledgement is not received? Because in previous example, I said if sequence is not transmitted correctly, then a server is going to ask. But how about the acknowledgement? If acknowledgement fail, then after some time, the client will ask for the acknowledgement once again. So that thing is called positive acknowledgement with retransmission. Okay. Then what is socket? This is very important terminology is being used. What is the socket number? What is the when you are using IP address with port number is called socket. For example, if I'll say 192.168.100.1 with port number 443, the combination of IP with port number is called socket. Okay, and rest of these questions you have to solve and submit to the GSS. So with that, our TCP and UDP session comes to end. And thank you for your time.